In August 2024, the United Kingdom's Committee on Fuel Poverty released a stark assessment. Despite significant policy interventions, fuel poverty reduction has flatlined for 5 consecutive years. Massive infusions of state capital and targeted subsidy programs have yielded virtually zero progress in the official metrics. This stagnation suggests the intervention strategy is missing the target. The failure lies in the measurement algorithm itself. To understand why governments misallocate these resources, we can examine the technical frameworks compiled by the Brazilian Energy Research Office. Their analysis reveals how different nations define and track energy deprivation. A global survey exposes a sharp geographical divergence in how the crisis is categorized. In the Global South, energy poverty is defined by a physical lack of grid infrastructure. The crisis is measured by reliance on solid biomass fuels like wood and agricultural waste for basic survival. In the Global North, the infrastructure exists. Here, the crisis manifests through a combination of domestic affordability limits and severe housing inefficiency. Before a state can allocate intervention funds, it must reduce these complex physical and economic realities into a measurable mathematical indicator. You cannot solve a socioeconomic failure state if your baseline algorithms are measuring the wrong variables. To legally define who qualifies for state energy subsidies, governments must map demographic data to establish a strict threshold. This scatterplot establishes our baseline framework. We map household income along the x-axis against total energy expenditure on the y-axis. When we plot actual population data, distinct demographic clusters form based on earnings versus how much is spent to keep the lights on. In 1991, policymakers introduced Metric 1, the 10% rule. This established a hard mathematical boundary. Any household spending more than 10% of its total income on energy is officially classified as energy poor. This calculation successfully captures low-income households struggling to afford winter heating. They fall above the line, validating the original intent of the policy. However, plotting the entire population reveals a severe algorithmic false positive. Notice this cluster on the far right. These are wealthy households residing in massive, inefficient homes that consume excess electricity and gas by choice. Because their sheer volume of consumption pushes their bills over the 10% threshold, the law categorizes them as energy poor. As a result, state subsidies intended for the vulnerable are siphoned off to those who do not need them. A strictly financial ratio collapses because it cannot mathematically separate enforced deprivation from voluntary overconsumption. Recognizing this failure, statisticians introduced an evolutionary step in policy measurement: low-income, high costs, or LIHC. This updated model changes criteria. Energy costs must exceed the national median, while residual income falls strictly below the poverty line. By isolating this data intersection, LIHC eliminates the high-income outlier problem entirely. It restricts qualification to a single, tightly defined quadrant. Yet LIHC harbors a lingering flaw. It relies entirely on relative economic medians to define poverty, ignoring the physical reality of the housing stock itself. To address this, the metric evolved again into low-income, low-energy efficiency, or LILE. LILE introduces a strict architectural parameter. To qualify, a dwelling must carry an energy efficiency rating of band D or worse. Our graph now filters the remaining data points by their physical efficiency dimension, removing households that are economically strained but structurally sound. LILEE isolates the root cause of the poverty. It identifies the exact households where high bills are the direct result of decaying infrastructure. Band D architecture means unsealed walls, drafty windows, and poorly insulated roofs. It means expensive thermal energy bleeds directly out into the freezing air. Transitioning to the LILEE metric allows a government to stop treating a recurring economic symptom and start curing the underlying infrastructure disease. But even LILEE assumes that high utility expenditure is the only reliable signal of energy poverty. This assumption masks a critical blind spot known as hidden energy poverty, which is measured by the M/2 metric. This graph isolates households that fit the M/2 formula. Their absolute energy expenditure is exceptionally low, dropping below half of the national median. These dots do not represent highly efficient homes. They represent populations enduring severe energy deprivation. The human reality behind this data is strict self-rationing. These are individuals sitting in freezing temperatures with the lights off, entirely to avoid utility debt they cannot pay. Prolonged exposure to unsafe indoor temperatures creates cascading public health externalities, from severe respiratory illnesses to compromised immune systems. Because traditional metrics are built to find high expenditures, they render the most vulnerable citizens completely invisible to the state. The mechanics of these algorithms reveal a broader truth. Measuring the economics of energy poverty is only a fraction of the human rights framework known as energy justice. Energy justice is built on 3 architectural pillars: distributive, procedural, and recognition. Advanced metrics like LILEE and M/2 fulfill the distributive pillar by identifying who needs the resources, but distribution alone is incomplete. The second pillar, procedural justice, mandates strict impartiality and safety in decision-making processes like grid disconnection. Consider the legal framework implemented by Cyprus. Cypriot law enforces procedural safety by requiring state regulators to thoroughly analyze a customer's specific health conditions and marital status before any utility shutoff is authorized. The final pillar is recognition justice, which demands that state definitions integrate unique cultural perspectives. New Zealand integrates this by writing the Maori concept of whānau directly into their national policy, evaluating energy hardship through the welfare of the extended family and communal living structures. The European Energy Poverty Advisory Hub now recommends that true policy must triangulate all these factors. It must account for low income, high prices, and inefficient stock simultaneously. Eradicating a 5-year flatline requires governments to stop tracking mere expenditure. Progress depends on engineering multi-dimensional algorithms that capture the physical, procedural, and social realities of the built environment.